All right, so first off, since the online students watch this, does everyone remember how the microphone?
So much more.
Yeah, so if you're like in this part of the room, you can still have your secrets. If you're over here for some reason, and you think you're whispering to each other, that microphone is going to pick up everything you say.
Because I entire thing twice, and Sammy wanted to do my hands, I wouldn't know. Like your whole personal life.
So we have an angle gamma measured counterclockwise from the positive x-axis. That is 132 degrees. We're going to calculate the vector components based on 3 different angles. And it's really just about where your triangle is. You have to find your triangle, you have to look for your adjacent, your opposite, and then you have to pick the proper trig function. First off, let's try to figure out what theta and phi are. So how do we find theta?
1.
Yep. So that's going to be degrees. Now, technically, this is the theta is measured counterclockwise. You could work with it by calling it a -48. The point is that when you're done, you want to make, since you're in the second quadrant, you want to make sure that your x component's negative, is going in the negative x direction, and your y component's positive. What about phi? Yeah, how do I find it? Yeah, so theta and phi share a 90-degree angle. Okay, so now we have all the angles that we need. So first off, does everyone see how theta and phi share a 90-degree angle? Okay, so every quadrant is a 90-degree angle with the x and y axis. Okay, so let's just start by working with theta. We're going to find the components based on that. So which component is opposite? Which one's adjacent?
Sine is opposite.
Yeah.
Well, sine is opposite, but which component? The y. So y is opposite, so it's going to get the sine function. The x component's adjacent, it's going to get the cosine function. Okay, so that's going to be the magnitude of your force vector F times the cosine of theta. We should get about 4.82 newtons. However, since theta is an acute angle, it's always going to give you a positive value, but you know that in quadrant 2, your x component's going in the negative direction. And it's because you're in quadrant 2, so you put a negative sign on it. Your Fy is going to get the sine function. And another way you can think about this is if you're looking at your components and you figure out which sine function one of them gets, the other component gets the other sine, it gets the other function. So it's like, well, I know x gets cosine, so y has to get sine. And this was going to give you 5.35 newtons. We leave that one positive because your x component is pointing up. Now, what if we started finding things based on phi? So here's a question. Which component, so let's look at the x component. Which sine function does it get? All right. The Friday. Do you know why it gets the sine function? It's opposite, the x, so if we're looking from the perspective of angle phi, the x component is opposite of that angle, so you have to now give it the sine function. We solved for phi, and that gave us 42 degrees. When we calculate this, we get the same 4.82 newtons, but it's in the second quadrant, so we have to make that a negative 4.82 newtons. And so then, since the x component got the sine function, the y component then has to get the cosine function. But if you look at the angle phi, the y component's also adjacent to the angle, so it's going to get the cosine function. And this will give you back your 5.35 newtons.
Is there a reason why we used 42 on the theta?
Well, oh yeah, I just wrote down the wrong angle. Now, when we have an angle measured counterclockwise from the positive y-axis, that's our gamma. So that's going to be this angle right here. It's measured counterclockwise from the positive x-axis. In this case, we can use our generalized functions, our generalized equations. And what are the generalized functions? They're the equations that you get from solving for the components in the first quadrant. So fx would be what? Magnitude of the force vector times what? Which trig function does it get?
Cosine.
Cosine. Now, the great thing about this is when you put this in, so you have your 7.2 newtons. Cosine 132 degrees. The great thing about these generalized functions, if you have that angle from the positive x-axis, the calculation will automatically give you the proper sign. So the cosine of any angle between 90 and 180 degrees will give you a negative sign. Well, actually further than that, between 90 and 270, it'll give you a negative sign. Does everyone remember your degree circle? Your four major axes, so your x and y axes, you'll go from 0, 90, 180, 270, and then 360 is at the 0 point. So then the fy, the y component. Oh, hang on. The proper angle. Yeah. Okay, so that means we're going to get the 7.2 newtons. Sine of 132. And you're going to get your 5.35 newtons. So now, me personally, I just like to see the angle that I have, make my triangle, and figure out which trig functions I need. I always thought that was easiest. If you want to, you can take the angle you have, you can do some math to figure out what the angle is from the positive x-axis, and use the generalized formats. Still, I just think it's better to just place your right triangle and go from there. Okay, what are we gonna calculate now? What about one in here? Okay, so what are we gonna have? Let's look at where our components are first off. One there. So that's gonna be fx, fy, based on the angle that we're looking at. We also have that. And that. Because then we're gonna have theta, phi, gamma. Okay, so, well, definitely not to scale, but we'll just say, so our magnitude of our force vector is 8 newtons. Theta is 27 degrees. Phi is going to be 90 minus theta. So that's going to give you 63 degrees. Now, how would you find gamma? Add theta to what? 180. So when we're in the second quadrant, we have to subtract it from 180 because from positive x to negative x, it's a 180-degree angle. Well, now we've gone all the way to the negative x, that's 180, plus the extra theta. And so that's going to give you 207 degrees. Now, real quick, what are the signs on the components going to be? Both of them? Yep. So look at where it's at. So you remember we set positive x is that way and positive y is that way? Well, if I have a vector here, going that way is the negative direction. Going that way is the negative direction. So they both are going to have to be negative. People got done with trig and geometry in high school. And, oh, thank goodness. And you get into physics, you go, oh, crap. All right, so let's look at this from the standpoint of theta. Okay, so here we see our x is adjacent, our y is opposite. So x is going to be the cosine and y is going to be the sine. When you calculate this, you'll get 7.13 newtons, but it's in the third quadrant. So it's going to have to be a negative 7.13 newtons. You calculate this. 3.63 newtons, but Fy is pointing down. And we are going to drive vectors into the ground because especially next semester when you have to analyze fields, you want to make sure that you can do these without thinking about it. Okay, what about if we do this same calculation from the perspective of angle phi? Okay. Do the trig functions stay the same or are they going to flip? Huh? They're going to flip. Because again, now you see your fx is opposite the angle phi. Anytime it's opposite, that's your sine function. And your Fy is adjacent to angle phi. And so that's gonna be your cosine function. Okay, so you're gonna get, it's gonna be F sine of phi. And what we said phi was 63 degrees. Calculate this, 7.13. But we have to adjust it to a negative because it's in the third quadrant. And then when you calculate this, you get your 3.63 again. Adjust it to negative because it's in the third quadrant. Once we get through vectors, we'll get through material a little bit faster, but this just requires a lot of writing. Okay, let's look at angle gamma. Okay, now, you see gamma is again counterclockwise from the positive x-axis, so we can use our generalized formulas. So our generalized formulas cosine for the x component sine for the y component. Okay, so cosine of 207. That's automatically going to give you the proper negative 7.13 newtons. And the angle, the obtuse angle is going to automatically give you the negative 3.63 newtons. What do you think is easier, just making the right triangle or readjusting everything to flow from the positive x-axis? Yeah, I always kind of thought just making the triangle and looking at if your component is opposite or adjacent, and just kind of going from there. Just remembering your opposite's always going to be the sine function, your adjacent's always going to be the cosine function. And if you're using your calculator and getting weird numbers, make sure you are set to degrees. That is a mistake that I've seen happen quite a bit. People don't realize that they're still in radians. Okay, now today you can work in the groups with the people next to you. We're going to take about 10 minutes, and you are going to read this and see if you can figure out where the vector goes and calculate its components.
Did you say you're like
30 degrees clockwise.
That's counterclockwise. Yeah, so clockwise from positive x, which is over here.
So like. That's the positive y.
Yep, so positive y and positive x is going that way.
Yeah. Yeah.
So if it's at 30 degrees clockwise from positive x-axis, which part of the angle is going the other direction? Yeah, well, that's the thing with, when you're asking trig questions, there's not a great way to ask them if you're not fluent with the language.
That's only two.
And then going from 1 to 3, 4 quadrants. Sorry, positive x axis to the vector. So go counterclockwise is the positive x. And make sure you go to 1 to 3, 4 quadrants to start or.
Yeah, I think.
So your force vector is positive x.
He wants to find.
How would you figure out that?
So you find them with theta, and then you find them with the angle going counterclockwise.
Going
Nope,
here.
just kidding.
Starting from the x-axis. It'd be like this. It'd be like this.
So you're gonna have a vector going. First angle.
Oh wait, this would be. So we'll start here.
Does it matter where?
From the x-axis counterclockwise.
He said it doesn't.
Straight line, and that's not a circle.
Now, that's your theta.
Oh, yeah.
Because now it's.
I give this 60, right?
Now.
This would be 90. This would be theta.
But I have a slide.
I'm just trying to understand counterclockwise.
No, this is positive.
Like the trig stuff.
Our flies are gonna be.
So you measured, you're using this counterclockwise from the positive x-axis. So it'd be right here.
Yeah, so. Now we don't.
So it's gonna change the sign out.
Trying to find y-axis to make this force.
So 270 plus 5.
How much force do we need to apply to the fixed axis? So they give us the force space of 1.9.
Trying to write.
And the y-axis, but not the x-axis of beta.
So.
Oh no, that's not beta, that's something else.
Yeah, so the gamma is like.
Your angle theta.
Okay.
The other angle I want you to do is from positive x-axis counterclockwise. Around here.
Oh.
So they went with that angle.
So from here to there, 180.
Yeah. So positive x all the way around.
Well, these are the same. Would that just be 180 versus this or 180?
No, no, we're not one.
Y and X.
All the way around. 360. Now, that 360, I have a chunk taken out of it.
Oh, so what's theta look like again?
What, the letter?
Yeah.
So it's like a circle.
Yeah.
line.
This theta?
We'll end up using all these.
So how do we so if measuring counterclockwise, we'd be measuring this way, correct?
Yes.
So where does that come in? So this is 30.
So what you want is you want this angle from here all the way around.
Oh, okay.
You always go from the axis to
So
the
that's
right.
360 minus 30 would be this angle. Okay. That. 330. And what is this?
The what?
What would we call this?
You can call it phi, you can call it gamma.
It doesn't matter what we label.
No, you can call it A. What you label your vector, your angles, is up to you. Just as long as you keep your labels for your vectors and your angles distinct.
Was that what you're talking about? Making all the labels?
Yes.
Okay. So we
Yeah. I don't think
said that this angle is
Ah,
theta.
right.
So this has to go off.
So now you don't.
I don't think our angles ever
We
come.
don't need
No,
this one.
we're just doing two angles this time. The theta.
So theta, this is, when you figure out this angle. This is this.
Draw
So,
one
like,
line.
No, this is theta. This is phi.
Yes,
that angle.
that angle.
Phi theta.
Oh, okay, that's probably why.
Phi equals 330.
I just had to circle the line.
So those are
330.
Those are, yeah.
So then this angle.
And would this be the
330.
Okay, that makes a lot of sense. So we've been trying
You're
to
gonna
find
calculate
gamma.
based off theta.
okay, but is theta still
No, but we're measuring.
x cosine?
So that's not.
Draw your.
McDonald's.
Yeah, we need to figure that out.
We'll get our heads on so we see which way.
Now,
to go.
so I think the answer comes out as.
Yeah,
Oh no, this is 90.
90,
So it'd be 60.
that's your FX.
That is. That's that.
Okay, now, based on where theta's at. we're gonna-
Okay, so I'm
So
So we got 60 and 30. 30, 30.
it's gonna be the
So we got all our angles.
Sine,
cosine.
cosine,
Cosine is adjacent. Fy
sine is opposite.
Right.
Now we know.
So your Fy is opposite your theta, so it's gonna get your sine.
So this is opposite.
Sine, yeah. No, standard.
You getting it? Yeah.
Okay.
So you'll just put that 330 into
I mean, that's the
Fx
right
and
angle.
cosine Fy. So in this case, they're both the same, but it's not always gonna end up that way.
This is.
Ah.
I mean, why not?
Our data here, but then we found, that I meant about our sine.
Yeah.
Yeah, I knew it.
Okay.
Only one we're using it on was gamma. We came all the way back around.
Why did he draw it?
Big one. I don't know.
Yeah. I keep saying 7.
If I go all the way around, it
So
may-
FY.
Fix it. It's 30 degree truncate.
Force vector, because those are just equated. So what is that cosine? Are you doing cosine? Which ones are cosine? Cosine is adjacent.
Oh, it's the whole circle all the way into this.
Adjacent. Adjacent, same. Yeah, adjacent, right.
I got to there and then I was like, what the fuck? Why did I get 0? What is this? I was like, maybe it is red. Maybe I'll just go with it. I literally just clicked in my ears after you said so.
30, 30.
Way around.
Yeah.
Yeah, mine just went all the way around the circle. That's not how I measure it. However, my circle is stopped. So it's
Can I start my day?
So then how do I figure out what to have?
Do it for 90%. Okay.
I really do.
Which means we need to use this one.
Why did it give me some weird?
Oh, yeah. X is. Look, see, you're looking at this direction.
I'm not.
Sixty degrees ahead. I think so too.
That though, my answer is like.
You gotta figure out how to put that new. Why'd you put 4?
But I need to.
Sin beta?
We didn't have it. I knew we had it. 360 minus.
60 degrees.
No, F is X.
Okay, so let's start looking at this. Are we having fun?
Actually, yeah.
Okay, so our vector is in the fourth quadrant. So first of all, the problem just straight tells us that. Now, the vector is located 30 degrees clockwise from the positive x-axis. So positive x, 30 degrees. So I'm just going to try and draw this in here. It's going to be, we'll just say about right there. And so clockwise from the positive x-axis, going to go like that. Okay. That's your angle theta. The other angle you have to analyze is now counterclockwise from the positive x-axis. That angle there. So gamma. So our theta is 30 degrees. Our gamma. What's our, how do we find gamma? Yep. 360 minus theta, 360 minus 30, and that gives you 330 degrees. Because if you think about it, if I went all the way around, that's 360. And so, but what I did was I stopped at the vector, which takes a chunk of theta out of that 360 degrees. So it has to be 360 minus theta. Okay, so then we can figure out the components based off each one of these. So let's go ahead and draw these in. Okay, so now if we're analyzing from the standpoint of theta, okay, fx is it adjacent or opposite? Adjacent, so it gets what? It gets what function? Cosine. And that means I mean, fy is opposite, but I don't even need to analyze it since I know that fx has to get the cosine, the fy has to be the other one. So then I'm going to put my numbers in. We saw that the magnitude is 4.9 newtons. 30 degrees. And I'm going to get 4.24 newtons. And based off where the vector is at, is x going to be positive or negative?
Positive.
Positive, because the x component points in the positive x direction. So I still like drawing, I still think it's helpful to draw the little arrowheads on the components. That way you can see if they're pointed in the positive or negative direction. So that means your fy this is going to give you 2.45 newtons, but based off the direction of Fy, I have to adjust this to what? Negative. Okay, now let's analyze from using gamma. Well, since gamma measures counterclockwise from the positive x-axis, what equations do I use?
Wait for you.
Yeah,
You would use cosine.
cosine for, so the standard ones.
Yeah.
So remember your standard component equations, if you ever want to figure them out again, just draw a vector into the first quadrant, figure out your components, with your theta being counterclockwise from the positive x-axis. Those are your standard components. Now, the great thing about this, oh, sorry, that's gamma. I put the 330 in, my calculator will automatically give me the proper sign. Okay. Now, I'm gonna go backwards. Sometimes you already know your vector components and you need to find either the magnitude of the vector or you need to find its direction. Okay, so let's think about this from so these are going to be your formulas here. If you remember these formulas for direction and magnitude, you're going to be fine. Let's think about where they come from. The magnitude component there, the magnitude formula there on the left, what does it look like? What is it? The Pythagorean theorem. So let's go ahead and say I have a force vector. I'll try to make these neat. I have my two component vectors. I have theta. So for my, so you want to know the magnitude is how long is that vector f? How big is it? Well, this is a right triangle. So I can say s squared fx squared plus fy squared. That's your Pythagorean theorem. Or usually when you see a, b, and c. So it's going to be your hypotenuse squared equals the addition of each side squared. Pythagorean theorem. So then I just take the square root of both sides. What did I just do? Have you ever seen that notation before? Okay. So always remember that you can either draw the square root sign or you can just raise it to an exponent of 1/2. That's the same thing. So for example, if you wanted to cube root something, you could draw the cube root symbol or raise it to what exponent? 1/3. So when you have a fraction as an exponent, it's going to be a square root or a cube root or a fourth root. Same thing. So that's going to give you your magnitude. Let's think about why our direction is, why we have that format for theta. Okay, well, if I know my fx and fy, how do I relate the sides of a right triangle? Which trig function relates the sides? Tangent. And tangent is what over what? Opposite over adjacent, so Fy over Fx, so then I'm just gonna inverse tangent both sides. And so I end up with the direction formula. Using that formula and figuring out where that angle theta is, that does take a little bit of practice, but we'll get used to it as time goes on. Because sometimes you'll have a vector in the third quadrant and theta will come out to be like 30 degrees. And you're like, how? Well, you just got to look at your triangle and figure out where that theta goes. But as you practice it, it becomes more intuitive. Okay, so let's say you're doing some, let's say you're out doing some work. So you're moving your tiller, you exert a force on the handles, the components, and you're moving it, and your force vector that you put on the equipment, your components are 85 newtons in the x direction and negative 132 in the y direction. Okay, first off, what quadrant is this in? Fourth, why?
Because X is positive and Y is negative.
X is positive, Y is negative. And so, X is points up. What are the magnitude and direction of the force? Okay, well, let's go ahead. We'll draw a diagram. Make my fourth quadrant bigger. So we see positive Y, positive X. I know that it's going to be somewhere into the fourth quadrant. Okay. Let's look at my components. And at least for now, we're going to say theta is right there. Okay. So first off, I want to know the magnitude of that force vector. Well, if I was doing this on an assignment, I start with my equation I'm going to solve. I don't have to do any more solving because it's already in the proper format. And then, well, I see my Fx is 85. My Fy is a negative 132. I'm going to square those two numbers, add them together, take the 1/2, take the square root, and I'm going to get 157 newtons. Now the direction. Okay, well, I'm going to start with, let's solve this equation. Numbers, negative 132 over 85. Take the inverse tangent, and theta is going to be a negative 57.2 degrees. Does that make sense? Why would that make sense? Look where theta is. Which direction is theta measuring? Clockwise. And clockwise from the positive x-axis is what sign on your angle? Negative. So you can figure out theta first and then go, oh, well, theta has to be that angle there. So you end up practicing with it and you end up figuring out how it all works as time goes on. But those are your formulas for solving for magnitude and for direction. Now, This is the part you're really gonna wanna latch onto. Adding vectors by, yep,
Scroll up real quick. Right there.
adding vectors by component form. Once you figure out your components, adding the vectors together becomes really super simple. Okay, so let's just say, for example, I add together vectors A and B and I get vector C. Okay, now C is also going to have its components, Cx and Cy. The question is how do I get those? Well, I'm going to have vectors A and B. I'm going to find out their components. So to get the X component of C, I add together the X components of A and B. You get the Y component of C, AY plus BY. What about a vector subtraction? Right now, I'm just going to show you how it works. As time goes on, it'll make more sense why it's this way. So for CX, what do you think I do? Right, so I'm going to do AX minus BX. CY, AY minus BY. So once you know the components of multiple vectors, you can just start adding those components together to get to your total vector. So you go from A plus B to get to C. But we do have to take this a little bit further. We're going to talk about unit vectors. So unit vectors, okay, you see how all these have a little hat on? That's how you pronounce them. It's like I hat, J hat, K hat, or X hat, Y hat, Z hat. I don't care which ones you use. You'll see me predominantly using I, J, and K because that's the classic way to do it. But these unit vectors are going to have a magnitude of 1, and they are going to then define the space that your vector is in. So for a Cartesian system, they define your rectangular coordinates. And so when you put these unit vectors on your components, that tells you that that component is this large in either the X, the Y, or the Z direction. So it's like, for example, if I do a tiny little vector there, that means that vector is going in either the I hat or the X hat direction. Same thing. Do a tiny little vector there. J hat or Y hat. Again, if you don't want to remember I, J, and K, you can go ahead and use the X, Y, and Z. And we're going to get to what's called unit vector notation. I'm going to show you what it looks like because we're almost out of time. So unit vector notation can also be known as vector component form. So if I have force vector F, I know that this is going to have an X and a Y component, okay? The way you write it, I get my X component, I hat. Whatever the X component, whatever that number is, the I hat tells me that that number is going in the X direction. Plus your Y component, J hat. And that's the classic way to write it. Or if you just feel more comfortable using X and Y, so I hat is X hat. It doesn't matter which format you use. So you wanna think of this as, I'm gonna have some number for this component, like let's say it's 9 newtons. Let's say your Fx is 9 newtons. Well, if I put 9 newtons I have, that tells me that I have 9 newtons of force only in the x direction. I have 7 newtons j hat, that tells me I have 7 newtons only in the y direction. And so if you get something that says write this in vector component form, this is what it means. Okay, so we'll pick this back up on Monday and we'll just keep chugging along on it. So you have to think of these unit vectors as outlining your space. So like in spherical components, it'd be rho hat, theta hat, phi hat, because they're outlining angles and then a position.
Oh, we did?
So these are gonna define the space that you're in.
What time do you wake up?
It just makes it worse.
Same.